Okay, so for this question, you got to find the second derivative. So we have to find the first derivative, and then we have to take the derivative of that. And because y and x are all kind of mixed up, it's not real easy to separate y with this cube. So we're going to differentiate implicitly, right? Implicit differentiation. So to take the derivative, and again, we're trying to find the second derivative with respect to x, really. So that's dy dx. So x is our preferred variable. So you do that, you do 3x squared, and then the chain rule would say multiply by the derivative of x, which is just 1. So that's why we don't have to do anything else. But over here, the derivative of this, 3y squared, now I have to do the chain rule on y, because this is with respect to x, not y. And so this is going to be y prime equals the derivative of 5 is 0. Okay? So now what we want to do is isolate for y prime. We have it in one spot. Okay, so we want to subtract 3x squared. Okay, so make sure you guys are doing this with me so you have the proper copy of this, okay? So you can study it later. Okay, so negative 3x squared, divide by 3y squared. You have y prime equals, now the negative 3 over 3 is negative, and then it's x squared over y squared. Okay, so that's the first derivative there. Okay, so how many of you got that first derivative? All right, yeah, did you get that? Okay. All right, so now where do we go from there? There's a couple other major steps that we have to keep in mind here. So now let's move this back up here. Let's keep going with this. So let's take the second derivative now. So second derivative, we realize that I need to do the same thing, dy dx, but I have a quotient rule here. So it's a quotient, so let's do quotient rule. The negative can just stay out front, that's no problem. We'll just leave that out there. So the derivative of the top is 2x times the bottom minus the top times the derivative of the bottom. So that's 2y y prime. Remember, because y is not our preferred variable, over the bottom squared. Okay, is everyone good with that step? It's at this point now where we don't want to leave y double prime in terms of x, y, and y prime. So here's where we have to do some substitution. So you see this right here? That's actually what y prime equals. So what I'm going to do is I'm going to substitute the y prime. I'm going to put this in here, negative x squared over y squared. Okay, so at that point you want to substitute, because we don't want the second derivative in terms of x, y, and y prime. So just x and y is good. That's what we need. Okay, so now it looks a little confusing here, but it's not too bad. So what we want to do is we want to say, okay, this y goes with one of these y's, because that's this negative and this negative are going to make a positive. And so what I'm going to have there now, y double prime, is going to be, so this is 2xy squared plus 2x to the fourth all over y, right? So, and this is over y to the, let me see, sorry, y to the 4, right? Because we want to square that. I don't think we squared that before, did we? The top of squared. Sorry, this should be 4. Okay? Are we good with that so far? So, in order to fix this, look at what we have to do. We have to get a common denominator up top. So I'm going to multiply y over y to this one, so that we have a y on the bottom. And what you also want to realize is that when you have two fractions over y, you can just combine them, right? Combine them up front. So this is going to be still a kind of a negative out front. That's going to be 2x y cubed plus 2x to the fourth. That's going to be all over y to the fourth. And when you have this, over y to the fourth, you can write this as negative 2x y cubed plus 2x to the fourth all over y to the fifth. And we'll make sure that negative is just out front, right? Okay? So we're not quite done there yet. So I'm going to just kind of erase this. Let's go back here and we'll continue on with this. So we're getting close, but we're not quite done yet, are we? Now, can I factor anything out of here? Yeah, I could take a 2 and an x out of there, couldn't I? So let's go up over here. So that's right, I can take a 2 and an x out actually. And I'm left with y cubed plus x cubed. See that? All right, so that's pretty good. And normally everything is factored out. All the like terms are gathered. We've got factored form. There's one final step here. I don't know if you guys have seen this from the work that you've done in your homework. There's one final step that we should do to completely simplify this. Sorry? Yes, that's exactly right. So if you notice that in the original question, there's another substitution that we can make. Do you see how we have the same parts here? So this actually equals 5. So that's the final sort of piece to that. Okay, so I don't think any of you quite got that, but this could be 2x and then just times 5. You see that? Or y to the fifth. So your answer then, actually let's put the answer up here. The answer then is negative what?
10x.
Negative 10x over y to the fifth. And that would be your most simplified version of that answer. So let me bring that down. Okay. That's how you do that one. So implicit differentiation with a couple substitution, substitutions there. Okay.